Okay, question 2, you need to see. So I'm just going to zoom over and show you. Okay. So it says, considering the following, assume that each point lies on the grid. So that there and that there, and this is there and this there. The length of the vector W is that. The vector W is that, what is its magnitude? So you click on this guy, and isn't the magnitude this guy squared plus this guy squared inside the square root? So you're really writing down a formula. So you go square root. Oh, I remember this question. How do you write A1 squared is the problem? You use that button. So you go A, hit that button, squared, 1. So there's A1 squared plus A, hit that button, A2 squared. So if the vector W is made up of A1 and A2, that's its X and Y component, then the magnitude will be this guy. So it might have just been how you make WebAssign do that, right? It was just knowing that there was a special button, and that was good. Now, might as well finish it since we're here. So the length of vector U is, well, if you look at this vector, isn't it 1 and 2? So what's that, square root of 5? I could do that in my head. Yeah. I might have to shrink it a little bit to see the next piece of the puzzle. Now, if we know that the length of the vector W is L, and that the angle, or direction as they call it, is theta, how will we write down what the vector W is? Well, again, they're wanting you to do a formula, and we're going to do that version. And the X component is L times the cosine of theta, comma, L times the sine of theta. And I may have to go back and fix some brackets here. Yeah, it's not the friendliest guy in the world. Yeah. So you're basically just writing the X component as L times the cosine of theta, and the Y component is L times sine theta. Typically, wouldn't we just call that the magnitude, right, of W instead of an L? So that was a formula question. Does that answer what you need from 2?
Yes. I thought I was supposed to enter a completed
number or something. Okay.
Yeah.
Let's look at 27 then. Oh, Katie, do you recognize question 27?
Yes, I do.
So my problem with this is I got the true speed of the jet accurate. So my speed is 55 miles an hour and the jet speed is 770, I believe.
Right.
And its true mile an hour is 799, but the direction of the jet I got wrong.
Okay, I know exactly what, I believe I know exactly what you've done. So let me, okay, I've lost you guys. Hold on a second. I've closed the window now. I can't find you. There you go. You've done the whole story and you've basically got, that's the true direction of the jet, right? The jet's trying to go this way and the wind's trying to blow it that way, but this is the jet, right? And you got that number and you're cool with that. And then you said you got an angle. Now, let's say, just for argument's sake, that the angle that you got was theta's 110, which makes perfect sense, right? It would be something like that. And you don't get the right answer when you put it in the box. And that's because of this guy. When you do questions involving things traveling, we don't use the angle in respect to the x-axis. That's what we do in math. The angle is actually this angle here. So I know that's 90. So this bit here is 20. And so the angle you will write down will look something like this. North, 20 degrees west. And if you look really carefully, don't they have a north and a west either side of your guy? So I bet you that's what you did. So if you take your number and knock 90 degrees off it or add 90, it depends, because your question, it might be over here, right? In which case that's a slightly different, right? Let's suppose it's over here and that's 30, you will say 60, right? But I'm pretty sure it's over here, your angle. At least the one I've got is.
And so for
the answer I got is, you finish.
Okay, the way to read the direction for these questions, it's starting north with a 20-degree tilt toward the west, right?
Correct.
Okay.
That's what that means. Now, we're using two different ways of measuring angles. There's the math way of measuring angle, which is you start at the positive X side and you measure the angle going anti-clockwise, which is what the 110 or whatever you got is saying. But when you do directions, north is counted as more important. And what you do is you tell people in relationship to north where you're going. So this would be, for instance, north 20 degrees west. And this guy over here might be north 30 degrees east. Right? So you would have to convert your answer into what does that look like when you do it this way. Does that help? You're checking to make sure what I said is right. If not, there's something else wrong.
Yeah, so I don't think that is the solution.
Okay, let's do it then. I don't think, oh, they may change the velocity. Okay, so they do change some things. So here is that question right from the beginning. You have a jet going this way with an angle of 30 degrees to the west of north. And I'll call the jet V. And I know that the velocity of the jet, which is the same as its magnitude, is equal to, let's use your numbers. What is the velocity of the jet in your question?
770.
Okay, not far away from me. I'm assuming that angle there is 30 degrees, agreed?
Yes.
Right, and then what you have is you have wind blowing this way. So if we put the wind vector over here, and I'll call this W. The magnitude of the wind is
That's 30 degrees for me.
right, so it's 30 degrees going this way. And what's the velocity of the wind?
55.
55. Now, what you don't have, but we will need, is the x-axis, because we measure angles from the x-axis. So let's do the vector v, which is the jet. It's going to have an x component, the magnitude of it, times the cosine of the angle that it makes with the x-axis, and the magnitude of the vector times the angle it makes with the x-axis. Now we know the jet is 770. What you don't do is use that number. That is only telling you this is 30. Our angle is measured from the positive x-axis. So that means that this angle here is 120 degrees, and then it's going to be 770 times the sine of 120. And on my calculator then, let's see what the jet does. It's 770 times the cosine of 120, which is negative 385. And then if you do 770 times the sine of 120, you will get a rather ugly 668.83. So that is the vector V. That's this guy here, the jet. And this here is wind blowing. Now I'm going to do pretty much the same thing again, but with the wind. So the vector for the wind is going to be the magnitude of the wind times the cosine that it makes of the angle it makes with the x-axis, and the sine of the angle it makes with the x-axis. And the wind was, I don't know why I put degree there, keep doing that, was 55. And the angle that we're talking about is not that 30. The angle we are talking about is the angle it makes with the positive x-axis. So if that bit's 30, this bit is 60. So this guy here is a 60 degree, and then it's 55. The sine is 60 degrees. Are we cool? So 55 cosine of 60 gets me 27.5. And 55 times the sine of 60, that's going to get me 47.63. And now we have the wind. So the first question, which is the one you were answering, asks us to find the true speed of the jet. Well, let's get the true vector for the jet first. And that's made up of the jet and the wind interacting. So you add them together. And the jet is this guy. And then you add the wind, which is this guy. And the true vector for the jet is that guy and that guy. So what's that going to be? Negative 385 plus 27.5. And that ends up being negative 357.5. And then this guy and this guy. So we get 666.83 plus 47.63. And that comes out to be 714.46. And now we can answer the question, which is what's the true speed of the jet? And speed is a number. It's the magnitude of this vector. And if you want to find the magnitude of a vector, you square the components. Oops, that's decimal point should be here. You square the component and add them together. And on my calculator then, it's going to be the square root of that guy squared. So that's what my bracket should be there. 357.5 squared, add a 714.46 squared, and I get 780, no, let's try again, 798.9 miles per hour. Does that look about what you got the first time?
Yes, that is the speed I got.
Perfect. Now the second, so if you want to think about what the heck's going on here, if you have the jet trying to go this way and the wind is kind of pushing it that way, it's not a surprise that the jet gets blown a little bit off course, right? It goes to about there. And the speed is that, right? And this vector here is telling you go negative 357 and a bit, go up 714. So you could draw it if you wanted to. Now, the second piece of the puzzle is they want to know the direction of the jet. And what they're really talking about is for this vector here, find the direction. Well, we can find the angle it makes with the x-axis. It's the inverse tan of the y component divided by the x component. Right, you remember that? Inverse tan of y over x. Now that's a really ugly number, so let's let the calculator sort it out. And before I actually hit the buttons, just looking at this picture, will you agree that the angle I'm looking for is in the second quadrant? You can tell it's in the second quadrant, right? Now, when I put this into the calculator, I am not going to get the one I want. I'm going to get an angle that works, but not in the right quadrant, right? So we're going to have to fix that in a minute. But let's do this bit. Inverse tan, 714.46 divided by 357.5. And we are looking, oops, I forgot to put my negative in. Let me do that again. Inverse tan of 700.
Well, I got negative 63.42, so you could just write that down.
Okay. So we should get exactly what you should, there we go. Just, you nailed it. So you are 90% done. Now, if this was a test question, right, an exam question, you've already got 90% of the points. So it's not like you're going to get nothing, right? You've already done everything you should have done. So now we have to do the last bit of the puzzle. And I'm going to try and draw a picture of what the heck's going on. If you look at this angle, aren't they telling you essentially this guy down here? Great. Right. That's not the guy I want, right? That's the guy I want. That's not him. That's in the fourth quadrant. The guy I want is this angle, right? So how do I get from this guy to that guy? What do I add to this to turn that
180.
angle, right? So I'll now add 180 and I'll get a better, but still not correct, angle. So add 180 and you now get 116.6 degrees. I've just rounded off, right? And that is correct for that guy. But they don't want the angle. They were very specific in the wording. They want to know the direction of the jet. And when you look at it, it has an N, a box for the answer, a degrees, and a west. So the guy they're really wanting us to figure out is him.
So you just subtract 90.
So now we have to do what you just said. And so that comes out to be, I believe, 26.6 degrees. So unless I've actually done the exact same mistake as you, that should be the correct answer.
No, I just entered 63.4 and variations of that.
Have you tried 26.6 yet?
I have not.
Now, the advantage, while he's doing that, the advantage of showing every single thing here, right? That when I grade it, can't I see that he did 90% of it right? And so I can give him, you know, if it's 20 points, I can give him 18. Because really the only thing he failed to do was to go from here to here. Now, you might have done 116, which is actually like 94% done, right? You're almost there. All you had missed there was the last little piece of the puzzle, right? So everything that you show me, if the method is correct, you're getting points for. Plus, you know, somewhere between here and here, isn't there a chance that I forgot a negative sign? Yeah, I reversed a digit, you know, instead of 5, 6, I wrote 6, 5. But I'm doing the process right. That doesn't penalize you too much because I tend to look at what you did as well as the answer that you got. And it's just as important. Okay. I know that's a difficult question. But hopefully that's made it a little bit easier for everyone. Okay, where are we off to next, guys?
Can we do some examples of half angle formulas again? Like half angle problems?
Sure. Half angle formulas coming up. Okay, I'm going to have to close that. Oh, that's okay. For a horrible minute, I thought I'd closed the whole thing. Give me a minute. I'm going to find half angle formulas because it's just easier to pick ones that they've got, because then they should come out nicer than just random ones. Oh, I'm not sure. Give me a second. I think it's in 7.3. If it's not in 7.3, it's 7.2. Double angles. Yes, it's 7. Okay, so I've got the correct place. So half angle formulas. And we are going to be looking at 7.3. And I'm going to hopefully, good, I still have it. I'm going to be using a unit circle for this question. So there are a couple of kinds of questions that you can get in these situations, right? Most likely one would be find the cosine. And the key word here is find the exact value of that guy. And the question says, use an appropriate half angle formula. So you don't need to worry about, do I use it or don't I? If they mention it in the question, you know it's going to happen, right? So far, so good. Right now, there are, and darn it if I've got it handy. Okay. Anybody got the cosine of the half angle formula anywhere handy? Because I don't have it. Again, I need
Plus or minus square root of 1 plus cosine over 2.
Cosine of theta all over 2. That guy?
Yeah.
Right, and there's another one then. Whoops. If you want to find the sine of a half, it would be 1 take away cosine of theta upon 2, right? And so on and so forth. Right, now, in this question here, first decision is important, but it's pretty easy to do. Is it plus or is it minus? Now, the simplest way to do that is, which quadrant is 22.5 in? Oh, dumb, that's the first quadrant, right? 22.5, right? Anything from 0 to 90, right? First quadrant. Since it is in the first quadrant, we now know it's a plus, because isn't the cosine positive in the first quadrant? Great. Now, suppose they had said to you the cosine of 112.5 degrees, right? And you're going to use a half angle formula. Cosine 112.5 isn't that guy in the second quadrant. And what's a cosine in the second quadrant, plus or minus? Second quadrant, what's the cosine?
Minus.
Minus. Do you see how you decide, right? Just look at the angle you're trying to get. And if it's a first quadrant, you do the plus version, and if it's the second. So I can now rearrange my formula just a tiny bit. So far, so good. Now, the half angle formula for 22.5 degrees means that I need to know who goes there. So you got to think of it like this. If a half theta is this guy, what will theta be? A half theta is 22.5 degrees. What will theta be? What number?
45.
45. Which means my guy is that guy. Great. Theta is 45. And then you just go square root of 1 plus, use your unit circle. Try and make it pretty. I tend to just do this. I don't think there's much else you can do to that. You know, square roots and side square roots don't really get simplified. You know, there's not a lot you can do them. So that's as good as the answer. And that would be the first kind of using a half angle formula, right? Now, there is a second kind. Suppose I tell you that the sine of theta is 4/5 and that theta is in the second quadrant, and I ask you to get the exact value of that guy, right? Half angle formula. So far, so good. Now, it's going to look very similar to that. If I go hunting for the sine of a half theta, I will find out that the answer is plus or minus the square root of 1 take away the cosine of theta over 2. Now, if I tell you that theta is in the second quadrant, but I don't know what the number is, I just know it's in the second quadrant, I can still tell you which quadrant a half theta is in. If I tell you that theta is in the second quadrant, if I put numbers to it, isn't that theta is somewhere in the range 90 to 180, agreed? That's the second quadrant. Now, if I take a half of it, then doesn't that make this somewhere there? And isn't that the first quadrant? Now, why do I need to know that? So I can choose plus or minus. And if you are in the first quadrant, would the sign of somebody that's in the first quadrant be positive? We're comfortable with that? Sine formula, and it's positive. And then I'll return back to my question. I need to know the exact value of cosine theta, right? Unfortunately, I don't know the exact value yet of the cosine of theta, but they did tell me that. So I'm going to build a right angle triangle. I'm going to make that theta. My opposite, my adjacent, my hypotenuse. Okay, get some cobwebs out of the brain here. What is the sine? SOHCAHTOA. What is the formula for a sine?
Opposite over hypotenuse.
Okay. So doesn't that mean then I know that this is 4 and this is 5? And can I just tell you that's 3, but if you wasn't a nice number, couldn't you do Pythagoras and get the third missing side? if you build this triangle, you can then find the cosine of theta. And the cosine is the adjacent over the hypotenuse. So the cosine of theta is 3/5. And now I'm going to do that. Why is the cosine of theta negative 3/5 instead of 3/5?
Because it's in the second quadrant.
Have you noticed that theta is in a different quadrant than a half theta, right? So if I'm finding the cosine of an angle in the second quadrant, it better be negative, which means I can now jump from this line to this line. So the sine of a half theta is positive the square root of 1 take away negative 3/5 all over 2. Now this one's going to come out a lot nicer. 1 plus 3/5 is 8/5 over 2. That's going to be 4/5. That's going to be that guy. And if you want to take it all the way to the end, there is your prettiest answer. 2√5/5 is the exact value of the sine of a half theta. How are we doing? You like that one? Make sense? Now, this question, and actually that one as well, but more likely this question, could be in a section 2. Because very often what you get in one of these questions is you're told this piece of information, and then they ask you for things like find the cosine of theta, find the sine of 2 theta, find the sine of a half theta. You ever have one of those questions where you find lots of different things using that information? Now, if it was done that way, this would be a section 2 question, right? Because there's lots to do. If it was just find the exact value of 22.5, which is this one, can you see that would lend itself well to a multiple choice, right? Short and sweet, you know, few lines of working, you're done. Something that's much more convoluted, you're more likely to get that in section 2 because of that. Right. Where are we off to now? Anybody got any homework questions? Anything that's kind of been puzzling them, whatever? Are we good? Yes.
Can we refresh what T-bar was?
God in himmel, you did give me a puzzlier question. T-bar is called, I'm trying to remember, reference angle, I believe its name is, isn't it? It's so rare for me to use that thing. If you take an angle, let's say.
We can't see what you're working on, by the way.
Oh, well, I can see what I'm working on, so I guess that's all that matters, right? Okay, here we go. If I give you this angle here is 30 degrees, then you might say T is 30 degrees, but its reference angle is also 30 degrees because it's the angle it makes with the x-axis, any x-axis. Now, if I gave you this angle here and I told you that this was 170 degrees, right? So we're talking a second degree angle. T would be 170 degrees, but its reference angle would be 10 degrees. Its reference angle is the angle it makes with the x-axis. Positive or negative don't matter. And can you imagine there'd be a third one down here and a fourth one over here? Reference angles are helpful when you are trying to find the second angle, when you know, say, the sine or the cosine. Give an example. If I went and told you that the sine of x degrees, right, blah, blah, suppose we solved the question and we found out that x degrees was 17 degrees. And I'd like to know the other answer, because there's typically two, isn't there? Right. Now, if it was a sine, and this angle here was 17 degrees, the place where the sine is positive, wouldn't the other one be over here? And it'd look like that. And wouldn't its reference angle be 17 degrees? And why is that angle important? Well, won't the second answer be 180 take away 17 degrees? Do you see, knowing the reference angle, and then you can just say 180, take that guy away, right? Now, suppose it was a different question and the other angle was down here. It would still make an angle, a reference angle of 17 degrees, but wouldn't your second answer be what, 360 take away 17? And that's how you would find the second one. Now, it's easy to do all of that when it's on the unit circle, because we don't need reference angles, don't we? Just need to find the other guy. But when the angle is, 17 and 42.1s and so on, and you know there's a second possible answer, don't you have to have a way of doing it? So these reference angles are just a way of saying, look, whatever your angle is, it will make that same angle with the x-axis in the other quadrant, right? So if I do one more of those pictures, whatever that angle is, so's this one, so's this one, and so's this one. Do you see that we can then figure out who the other guy is by, if it was 17 degrees, taking it away from 180, adding it to 180, taking it away from 360, right? We could get the other second missing angle by using the reference angle to help us.
So in the case of all four of those angles,
right,
when working with angles that are on the unit circle, is it just all of the angles that have the same denominator?
If you're looking at, say, in this case, let's give you an example. Suppose I'm looking at 45 degrees, right? And I want to find all the guys whose sine is √2/2, right? Well, I know 45 degrees is one of them, right? Because of that guy. Where is the other one going to be? Well, for the sine, it's over here. And so it's that one. So if you wanted to know what two angles have a sine of √2/2, it's these two here, which is what, 45 degrees and 135 degrees. Suppose I was wanting to know when the cosine was a half, right? Cosine x is a half. What did that do? Right, cosine is a half here, right? That's 60 degrees. Isn't the other one down here, right, at 30? Now, since the unit circle, I can just find the x or y coordinate that matches the guy I'm looking for. I don't need all this, right? But we could use it. Do you know how that's 60 degrees? Won't that make an angle of 60 degrees with the x-axis? Won't the other answer also make a reference angle of 60 degrees? And if you take 60 degrees, do you see you end up at 300? This is much more useful when it's not a unit circle, right? If it's not a unit circle, then this becomes much more important, right? Knowing this angle, I can then use it to get the others. Okay. I think we're about done.